basic introduction about the polynomials and what are the graphical representation of the polynomial. Let us quickly take a look over it. We discuss about the definition of the polynomial. Right? A polynomial is a mathematical expression or it is an algebraic expression that is expressed as a sum of terms having same variable but different powers. Right? That was the basic definition of the polynomials. Then we discuss about the degree of the polynomial. Degree of the polynomial basically means the highest power of the variable present in the polynomial is known as the degree of the polynomial. In the third thing, we discussed about the zeros of the polynomial. That value of the variable x, that value of the variable x at which the value of the polynomial p of x becomes 0 is known as the zero of that polynomial, or it is also defined as that real value k for which p of k is equals to 0. That was the basic definition of the zero of a polynomial. Then we discussed about the geometrical representation of the zeros, right? Sorry, geometrical representation of the zeros of a polynomial. So in case of a linear polynomial, the graph of the linear polynomial was a straight line. The graph of a quadratic polynomial was a parabolic curve. Again, we discussed there two subdivisions, that is if the value of a, what is a? The coefficient of x square. If the value of a is greater than 0, then the graph will be a parabolic curve opening upwards, and if it is less than 0, then the graph will be a parabolic curve opening downwards. And lastly, we discussed about the graph of a cubic polynomial. The graph of a cubic polynomial was simply a waveform. Right? Now, in today's lecture, we are going to discuss about the number of zeros a polynomial can have, then the relationship between the zeros and the coefficient of a polynomial, and lastly, we are going to discuss about the division algorithm of the polynomials. Right? So let us start with the first topic of today, that is the number of zeros a polynomial can have. So you can look over here on the board that I have drawn some graphs under the topic how to identify number of zeros that a polynomial can possess. This can be asked in a 1 mark question. Note that this can be asked in a 1 mark question. Suppose if I give you any of the graphs here, and if I ask you to find out the number of zeros this polynomial, the graph given here can have, then it will be very easier for you to identify this, right? So let us continue with this topic, that the number of zeros a polynomial can have from the graph is the definition, or basically how to understand it. It is number of times the graph of the polynomial touching or intersecting the x-axis. Right? This is the basic definition of the number of zeros a polynomial can have. That is number of times the graph of the polynomial touching or intersecting the x-axis. Strictly, it must be x-axis. Now, you might come with a question that, sir, x-axis on the big side are either positive or negative. Then which side we are going to consider? That means we are going to consider on both sides, either positive or negative. That means the whole x-axis starting from negative infinite to 0 to positive infinite. The whole x-axis. If it intersects or touches anywhere on the x-axis, that much number of zeros this graph of the polynomial given will have. So let us understand it by taking an example. I have drawn here some 7 graphs. There are some 7 graphs over here. We shall quickly identify them. The first one here is a polynomial having a straight line that passes through the x-axis only at one point, right? Then, according to the definition, number of times the graph of the polynomial touching or intersecting the x-axis, that one number of zeros this polynomial or this graph will have. So here, the number of zeros are 1. This will have 1 0, right? Because it touches the x-axis or it intersects the x-axis at this point only. So this graph will have only 1 0. Here you can see that as this is a parabolic curve, right? So this parabolic curve will define what kind of polynomial? This will be a quadratic polynomial. The graph, this denoting here, will be a quadratic polynomial. The graph that the p of x suggests or it describes here is a linear polynomial. Good. So how many zeros are there here? That is 1 and that is 2. So that is 2 zeros. Right? This graph will have 2 zeros. Again, if you look here, then that is a parabolic curve. It is a parabolic curve. So it will be a quadratic polynomial, and as we seen here in case number 2, that if it is a quadratic polynomial then it must have 2 zeros. But you see here that this graph touches the x-axis at one and only one point. Right? At one and only one point. Then how to identify this kind of question? That is, this is a special case when the polynomial will be a perfect square itself. So let me take an example, that is x square minus 2x plus 1, or you can also write x minus 1 whole square. Right? It is x minus 1 whole square. You can see that both the factors here are x minus 1 and x minus 1. So they are the same factors. That means the values you get here for x will be the same values. Right, so if I say that this is 1 comma 0, then I shall get 2 zeros here, but both the zeros are same, and so that 2 zeros will be considered as a single zero. So again, how many zeros will this polynomial or this graph have? That will be 1 0. That means both the zeros are same. If you write x equals to 1 or x equals to 1, both the values are same. So there is no matter in writing x equals to 1 or x equals to 1 because both the zeros are same. So this graph will have a single zero here, right? Now again, if you see here that the next graph is intersecting the x-axis at 3 points, so that will be having 3 zeros, right? So examples 1, 2, 3 and 4 are the graphs that we discussed in the previous topic. That denotes a linear polynomial, that denotes a quadratic polynomial, this also denotes a quadratic polynomial, and this denotes a cubic polynomial. So the basic thing that is, if p of x is a linear polynomial, then number of zeros will be equal to 1. Right? If p of x is a quadratic polynomial, then the number of zeros will be either 1 or 2. Either 1 or 2. Why it is either 1 or 2? Either 1. That means if the polynomial given to you, if the quadratic polynomial given to you is a perfect square in itself, then it will be having a single zero. And if it is a regular quadratic polynomial, then it will be having 2 zeros. Right? So that is 1 or 2. And if the polynomial p of x is a cubic polynomial, then that will have 3 zeros. Right? So linear has a single zero, quadratic polynomial has 2 zeros or 1 zero, and a cubic polynomial compulsory has 3 zeros. Right? Now we shall discuss some cases where the graphs do not intersect each other anywhere at x-axis. Right? The graphs do not intersect each other anywhere at x-axis. So in case number 5, you can see here that the graph of the p of x is a straight line. Parallel to x-axis. Parallel to x-axis, that means that graph will not intersect the x-axis anywhere. Right? So you can see here that if the graph does not intersect at x-axis, then the number of zeros that the polynomial will have will be 0. Why 0? Because that does not intersect each other. Who each other? The graph and the x-axis. They do not intersect each other anywhere, and hence the number of zeros are 0. In case number 6, you can again see that there is a quadratic polynomial. This quadratic polynomial is slightly above the x-axis. You can see some gap over here, right? It is slightly above the x-axis, and if it is slightly above the x-axis, it will not touch the x-axis, neither will it intersect the x-axis. So this graph of p of x, this quadratic parabolic graph, does not intersect the x-axis, so it will again have 0 zeros. It won't have any zeros, right? And again in case number 7, there is a waveform-like structure, a waveform-like graph, which again does not intersect the x-axis anywhere. So this graph again will be having 0 Is it clear or not? So this is basically how you can identify the number of zeros a given graph or a given polynomial will have looking simply at the graph. So there is no such thing that you cannot identify, right? Simply again take a look over here. In the first case, it is intersecting the x-axis at 1 point, so it will be 1 0. It is intersecting the x-axis at 2 points, so there will be having 2 zeros. Here, it is a special case where p of x, that is the quadratic polynomial given to you, is a perfect square in itself. So that is x minus 1 into x minus 1. Again, that is the same value, so it will have only 1 0. This cubic polynomial intersects the x-axis at 3 points, so that will be having 3 zeros. And these are the cases where the graphs do not intersect the x-axis anywhere, so they will be having 0 zeros. Right? So these are some of the examples. There are more examples given to you in the textbook. You can take a look over that and you can directly solve it from that. You can look at the graph and directly judge that how many number of zeros will the graph possess. Is it clear, everyone? So that is about identifying number of zeros. Is it clear, everyone? Good. Now in the next topic we are going to discuss about the relationship between the zeros and the coefficients of a polynomial. Right? So first of all we need to know about the coefficients of a polynomial. Coefficients basically means the coefficients or the values associated with the variable is known as the coefficient of that variable. Is it clear? So that is basically known as the coefficients, and then we are going to look at the zeros. The zeros that we already discussed in the geometrical representation. So let us take a look over here. Second topic of today, that is relationship between the zeros and the coefficients of a polynomial. Now, in this topic, we are going to discuss this topic, the relationship between the zeros of a coefficient and the polynomial, zeros and the coefficient of a polynomial, in a difference manner. Let us see how. Right. The first one we have is a linear polynomial. The second one we have is a quadratic polynomial. And the third thing we have is a cubic polynomial. Right? And we also know their general forms. The general form of a linear polynomial is p of x is equals to ax plus b. The general form of a quadratic polynomial is p of x is equals to ax square plus ex plus c. And the general form of a cubic polynomial is p of x is equals to ax cubed plus bx square plus cx plus d. Right? So these are the general forms of the given polynomials, whether it is a linear, whether it is a quadratic, or whether it is a cubic polynomial. Now, first of all, let us get the coefficients of the variables present in the polynomial. Right? So, what is the coefficient of x here? A. This b here is the constant term. So let me write it down here. That is coefficient of x and that is the constant term, right? Similarly here you can see that a, that is the coefficient of x square, b, that is coefficient of x, and c is the constant term. Likewise for the cubic polynomial, right? That is coefficient of x, constant term, coefficient of x square, coefficient of x, and the constant. Now we need the relationship between these. So first of all, let us find out the zeros of this. How to find out the zeros? The basic definition is let p of x is equal to 0. We will assume that p of x is equal to 0. That means we will assume that the value of the polynomial already associated is equal to 0. So if it is equal to 0, then what we can say that ax plus b is equals to 0, because p of x is equals to ax plus b, right? Therefore I can say that ax is equals to minus b, this plus b will go on the other side, and hence x is equals to minus b upon a. Yes or no? So we got the value of x, that is minus b upon a, right? Now if you closely look over b and a or a and b, then you will come to know that what is b here? Exactly the constant term. What is a here? Exactly the coefficient of x. So you can also write it as minus of the constant term divided by the coefficient of x. Yes or no? So minus p upon a is the zero of the given polynomial p of x, which is also equals to minus of the constant term divided by the coefficient of x. Is it clear everyone? So basically what can you say about the relationship between the zeros and the coefficient of x, coefficient of a polynomial is 0 equals to minus p upon a is equals to the minus of the constant term divided by the coefficient of x. Yes or no? Yes. So that is the first relationship that we derived for a linear polynomial. Is it good? So for a linear polynomial you can say that zeros or 0 is minus p upon a, which is equals to minus of the constant term divided by coefficient of x. If I directly use this formula, then I shall get directly the 0 of the given polynomial. Directly the 0 of the given polynomial. Let me see, for example, if I am having a polynomial p of x is equals to 3x minus 5, or let me say 3x plus 5 for now, right? Then what is the coefficient of x here? That is 3. What is the constant term here? 5. So the 0 of this given polynomial x is equals to minus b upon a, that is minus 5 by 3. You can check it out that the value of this polynomial p of x is equals to 3x plus 5 will be 0 at x equals to minus 5 by 3. That is the best example here, right? So again, the relationship between the coefficient of a polynomial and the zeros is x equals to minus b upon a, that is the 0 of a polynomial, and that is equals to minus of the constant term divided by the coefficient of x. That is the relationship between the zeros and the coefficient for a linear polynomial. Is it clear everyone? Good. Now coming to the quadratic polynomial. The quadratic polynomial has a general form of p of x equals to ax square plus px plus c. Good. Now the coefficient of x square is a, the coefficient of x is b, and the constant of itself is c here, right? As we discussed in the graph of a quadratic polynomial in the previous topic, that if the graph is a quadratic polynomial, then it will be having how many zeros? 2 zeros. We shall take the general term here. What? We shall not take the special case here, right? We shall take the general term. So let the zeros of p of x be alpha and beta. So what are these zeros? We have defined, we have assumed that let the zeros of the given polynomial be alpha and beta. Right? So if the zeros are alpha and beta, then we can define two relationships here. That is the sum of the zeros, and we can also define the product of the zeros. The sum of the zeros and the product of the zeros. The sum of the zeros basically that is equals to minus b by a, and the product of the zeros basically is equals to c by a. You can note here that if it was a linear polynomial, then the zeros or the zero of that polynomial was minus b upon a. Similarly here you will get the sum of the zeros as minus b upon a, whereas the product of the zeros was c upon a. Note that in a linear polynomial we had only one relation, whereas in quadratic polynomial if we are having two zeros, then we shall have two relations, right? So you can again assume that what number of relations will a cubic polynomial have. Is it clear? So let us go further with this. So the sum of the zeros is minus b upon a. Now if it is minus b upon a, then note that what is b here? Yes, good. B is the coefficient of x, that is minus the coefficient of x divided by the coefficient of x square, because a is the coefficient of x square, and c, that is the constant term divided by the coefficient of x square. Right? So again you can clearly look over here is, see the denominators of both the ratios, the sum of the zeros and product of the zeros. The denominator of both the ratios is same, that is a, and that is the coefficient of x square. So minus b upon a and c upon a, it is quite easier to remember that sum of the zeros is minus b upon a, that is minus of the coefficient of x divided by the coefficient of x square, and the product of the zeros is c by a, that is the constant term divided by the coefficient of x square. Now if it is written as sum of the zeros, then we are having the zeros as alpha and beta, then the sum of the zeros is represented as alpha plus beta is equals to minus p upon a is equals to minus the coefficient of x upon the coefficient of x square. Right? So that is the first relation of a quadratic polynomial. Right? Minus p upon a, alpha plus beta, that is sum of the zeros, alpha plus beta equals to minus b upon a equals to minus the coefficient of x upon coefficient of x square, and product of the zeros, that is alpha into beta, that is equals to c upon a, and that is equals to the constant term divided by the coefficient of x square. Right? So this is the second relation that we define for a quadratic polynomial. Is it clear? The sum of the zeros and the product of the zeros. Right? So that is the constant term divided by coefficient of x square. So again let us quickly look at what we studied till now. If it was a linear polynomial, the basic formula, the general formula is p of x equals to ax plus b. Now, finding out the relationship x equals to minus b upon a, that is minus of the constant term divided by the coefficient of x. In a quadratic polynomial, the general form is p of x equals to ax square plus bx plus c. That means, let the zeros of the polynomial be alpha and beta. As this is a quadratic polynomial, it will be having two zeros, so that the zeros be alpha and beta. So sum of the zeros, that is minus b by a equals to minus the coefficient of x upon coefficient of x square, or simply sum of zeros equals to alpha plus beta equals to the same formula that we written here, and product of the zeros, that is alpha into beta equals to c upon a equals to the constant term divided by the coefficient of x square. Right? So that was about the quadratic polynomial. Right? Now we are going to discuss about the cubic polynomial. Note that this cubic polynomials, the sum related to cubic polynomials are not asked in the board examination, but again it is quite an important one for the future purpose, that is in 1100 it is quite relevant for that. So we are going to discuss it here. Let the zeros be alpha, beta and gamma. Right? So how many zeros will this cubic polynomial have? As we discussed in the graphical representation, that the graph of a cubic polynomial is a waveform. That means it is minimum. It is intersecting the x-axis at how many points? 3 points. So I have assumed here 3 zeros for a cubic polynomial. Let the zeros be alpha, beta and gamma. Right? So these are the zeros that the cubic polynomial have possessed. So we are having again 3 relations here for this cubic polynomial, that is sum of zeros. Then this is an important one, sum of product of 2 zeros taken at a time. And lastly, the product of zeros. Right? We are having 3 relations here. Sum of the zeros as we had in a quadratic polynomial, product of the zeros again as we had in the quadratic polynomial. This will be new to you, that is sum of product of 2 zeros taken at a time. So we are going to take only 2 zeros at a time. We are going to multiply that. Then again we are going to take the another 2 zeros. We are going to multiply that, and we are going to add all of them. Right? So first of all, let us discuss sum of the zeros. That is minus p by a. That is minus of the coefficient of the coefficient of x square divided by the coefficient of x cube minus p by a. You can take out from the given polynomial, right? Then product of the zeros, that is c by a, that is the coefficient of x divided by the coefficient of x cube, and product of the zeros is again minus d by a, that is minus of the constant term divided by the coefficient of x cube. Right? If you look over here, that the denominators of all the 3 ratios are again same. As I said in the quadratic polynomial, the denominators of all the 2 ratios were same. Here also the denominators of all the 3 ratios are same. That is coefficient of x cube. In the numerators, you are going to take first of all minus p, then c, and then minus d. It is quite an easy way to remember. Right? You can memorize this. That minus b by a, c by a, d by a. See, this minus b by a is common from the linear polynomial also. That one of the only one zero that a linear polynomial possesses is minus b by a. One of the relations a quadratic polynomial possesses is also minus b by a. And here also one of the relations is minus b by a. See, this c by a is also common here. That is also c by a. This is extra that we have added here. That is minus d by a. Good. So sum of the zeros defined as alpha plus beta plus gamma equals to this relation that I am going to write it down here. Right? So sum of the zeros is equals to minus b by a. That is alpha plus beta plus gamma equals to minus b by a equals to minus of coefficient of x square divided by the coefficient of x cube. Right? So that is the relation. Then note that this is the most important one, sum of the product of 2 zeros taken at a time. That is, first of all, we shall take alpha and beta. We will multiply it. Then we shall take beta and gamma. We will multiply it. And we shall take gamma into alpha. And we will multiply it. After multiplying everything, simply add them. That is alpha beta. Alpha beta simply means alpha into beta. Right? Beta gamma simply means beta into gamma, and gamma alpha simply means gamma into alpha. It is not written like alpha beta, they are same, one variable. No. Right? that alpha beta, that is alpha into beta, beta gamma, that is beta into gamma, and gamma alpha, that is gamma into alpha. So we are going to first of all multiply these two zeros and then we are going to add them. So that is sum of product of two zeros taken at 10. Again, this is the second relation that a cubic polynomial will have. That is alpha beta plus beta gamma plus gamma alpha equals to C upon A equals to the coefficient of x upon coefficient of x cube. And last one, that is product of zeros, that is alpha beta gamma equals to the product minus b by a, that is minus of the constant term divided by the coefficient of x cube. Clear? So that is basically the relationship between the zeros of a polynomial and the coefficients of a polynomial in the form or in a difference manner. Right? So you quickly look over it, see and get it cleared right now. So I think it must be clear for you now, right? This is given in the book, but this is not given in this term. So it would be quite an easy task for you to identify each and everything if you write it down on a book and keep it with you, stapled in the textbook, right? Take out this from the video to the book written on a nice page. Get it stapled in the book and keep it with you. So it will be easier for you to identify each and everything easily. Clear with this, everyone? Okay, good. Now, let us solve some examples related to this. Right? Because there is no thing to study the theory without solving the sums. Clear with this? Okay. So let us move on with the examples now. I shall erase this thing. If it is not possible for you to write it down at this point, then you can also pause the video and take a screenshot of this. Right? It will be safe in your gallery. You can also do it there. Or you can also pause the video and then write it down. It would be easier. Convenience on you. Right? Now let us solve some examples. The first one is a polynomial given to you is 4x plus 7. Yes, what kind of a polynomial is this? Good, this is a linear polynomial, right? So first of all, let us find out the zeros. To find out the zeros, let p of x is equals to 0. Therefore, we shall say that 4x plus 7 is also equal to 0. So that we can say that x equals to minus 7 by 2. This is the 0 here, mark it at number 1. Right, so this is the 0 that we found out using the method. Right, this is the 0 that we found out using the method. Method, that means we let the p of x equals to 0. We let the p of x equals to 0 and then we have found out the 0. Right? Now let us look at the relationship that we derived here. The relationship that we derived here was x is equals to minus b upon a. What is this minus b upon a? That is minus the constant term divided by the coefficient of x. Right? That was the relationship that we derived for the linear polynomial. So first of all, let us identify what is a here, 4. What is b here, 7. Right? A equals to 4 and b is equals to 7. So replacing the value of a and b here, therefore we shall get x is equals to minus 7 by 4 again. Right? What is this? The zeros. What are this? The coefficients. Note that both the values are same. What you will note here is both the values of both the things, x is same here in both the cases 1 and 2. But the first one, that is the zero of the polynomial, and the second one is the coefficient of the polynomials or the coefficient of the variables and the constant term in the polynomials, right? So that is, we got here x equals to minus 7 upon 4. Now what we are going to do, that by 1 and 2, by 1 and 2, the relationship between the zeros and the coefficients is verified, right? Because both the values that we got here in 1 and 2 are same, and if they are same, then we can say that the relationship that we obtain or that we try to obtain is verified here. Is it clear, everyone? So again, you can take a look over it by yourself. You can solve some examples related to the linear polynomial in this. Is it clear? Now let us take another example. For instance, if I say x square is equal, p of x is equal to x square plus 7x plus 10. I am having this polynomial right now with me. So first of all, let us find out the zeros by our previous methods. How to find out the zeros? So first of all, we shall factorize this. So that is x square plus 5x plus 2x plus 10. Right? You must know how to factorize a quadratic polynomial now, because we have already studied this in standard number 9. Right? So that is equals to x into x plus 5 plus 2 into x plus 5. That is x plus 2 into x plus 5. So what is this again? We simply got the factors of the given polynomial. That is x plus 2 into x plus 5. Now to find out the zeros, let p of x is equal to 0. P of x equals to 0, that means x plus 2 into x plus 5 is equal to 0. Right? Therefore, x equals to minus 2 and minus 5. What are this? The zeros here. Thus, x equals to minus 2 and minus 5 is known as the zeros of the given polynomial. You can check it by yourself. How to check it? Simply by putting minus 2 equals to x in place of, in p of x, minus 2. You will replace x by minus 2 in place of this x in p of x, and we will replace x equals to minus 5 in p of x. If I get 0 in both the cases, then it is verified that these are the zeros. If we are not getting the 0, that means these are not the zeros, right? It will get to zeros. So, we got the zeros here, minus 2 and minus 1. Now comes the sum of zeros. How to find out the sum of the zeros? Before that, let me write down a point that let alpha equals to minus 2 and beta equals to minus 5. Right? Alpha equals to minus 2 and beta equals to minus 5. Therefore, sum of zeros, that is alpha plus beta, that is minus 2 plus minus 5, which is equals to minus 7, and the product of zeros equals to alpha into beta, that is minus 2 into minus 5, which is equals to 10. We shall take this both the values as equations number 1. Right, as equations number 1, that sum of the zeros, that is alpha plus beta equals to minus 2 plus minus 5 equals to minus 7, and product of the zeros, that is alpha into beta equals to minus 2 into minus 5, that is equals to 10. Now, we have just find out the zeros and the sum of zeros and product of zeros. Now we shall relate this with the coefficients. So, for the coefficients we require a equals to 1, b equals to 7 and c equals to 10 from the given polynomial. A, B and C, we require A, B and C. Also, sum of the zeros for a quadratic polynomial is equals to minus b by a, that is minus of 7 upon 1, which is equals to minus 7. See, this value 7 and 1, I have replaced it from A, B and C. Right? So that is minus 7 upon 1 and that is minus 7, and product of the zeros, that is equals to C by 8, that is 10 by 1, which is equals to 10. If you see here clearly, the sum of the zeros in both the cases, that means if I directly add them alpha plus beta, and if I get it by minus b by a, I shall get the same values minus 7. And the product of zeros also in both the cases, if I multiply them directly alpha into beta, or if I write it c upon a, again I shall get the same values, that is 10. So again you can say that by 1 and 2, the relationship of zeros and the coefficients is verified. Right? Hence it is verified. See, first of all what we did, we just factorized the given polynomial x plus 5 and x plus 2. So we got two factors. Then we let p of x equal to 0. So we got x plus 2 into x plus 5 equal to 0, and hence the value of x is minus 2 and minus 5. Now we got let that alpha equals to minus 2 and beta equals to minus 5. Therefore sum of the zeros after adding directly, that is alpha plus beta, we get minus 2 plus minus 5, that is minus 7. And product of zeros is alpha into beta, that is minus 2 into minus 5 is 10. Also we know that according to the coefficients of the value, so the coefficients of x square x and the constant of 1, 7 and 10. So we can get sum of the zeros, that is minus b by a, that is minus of 7 upon 1, that is minus 7. And product of zeros is c by a equals to 10 by 1 equals to 10. So by 1 and by 2 we can see that the relationship between the coefficients and the zeros of a polynomial is verified. So I think it must be clear to you now how to write down, how to solve a sum. If it is asked for coefficients, if it is asked for the relationship between the coefficients and the zeros to be verified. Right, let us take one more example of this. P of x is equals to 6x minus 3 minus 7x. Right, sorry, I made a mistake writing over here. That was 6x square minus 3 minus 7x. Right, so you can clearly observe here that first of all the terms here given to you are not arranged. The terms are not arranged here. So first of all let us try to rearrange the term 6x square minus 7x minus. Note that whenever you write down a polynomial, the terms of the polynomial must have the powers of the variable in the descending manner, in the descending order. Is it clear? The terms of the polynomials must have the powers of the variables in the descending order. That is the best way to write down of any polynomial. Sometimes the paper checker or the paper setter might trick you by giving you an example by rearranging the terms, by scrambling the terms. Right? Suppose they might give you an example for 1 minus x square. See, the terms are not arranged properly. So first of all try to arrange the terms in the powers in descending order and then start solving the sum. Note that basically you need to arrange the terms if it is not arranged. So first of all we arrange the terms here, 6x square minus 7x minus 3. Now we shall factorize this to find out the zeros of this given polynomial. So that gives me a factor 18, that is 6x square minus 9x plus 2x minus 3. Right? So that is 6x square minus 9x plus 2x minus 3. That means I am having a common factor 3x into 2x minus 3 plus 1 into 2x minus 3. So that is 2x minus 3 a common factor into 3x plus 1. Right, so these are the factors given to me or the factors that we got. Now finding out the zeros. So let p of x equal to 0. Therefore 2x minus 3 into 3x plus 1 equal to 0. Therefore I shall get x equals to 3 by 2 and minus 1 by 3. Right. And one more thing, let me do it here itself, getting the coefficients here. So a equals to, I shall get the coefficients not from the first step, I shall get it from the second step. A equals to 6, b equals to minus 7 and c equals to minus 3. Right. Why from the second step? Because in the second step we have rearranged the terms. So see, you can make a mistake over here. What the mistake you will do is, when taking out the coefficients, you shall take b equals to minus 3 and c equals to minus 7. If you don't, okay, so we got the zeros, x equals to 3 by 2 and minus 1 by 2. Now what we shall do is, let alpha equals to 3 by 2 and beta equals to minus 1 by 3. Okay, let us find out sum of zeros, that is alpha plus beta, that is equals to 3 by 2 plus minus 1 by 3. You need to add this. These are two rational numbers that are to be added. So that is equals to 9 minus 2 upon 6. Note that this plus minus will become minus. Right? Then we shall take LCM. 3 into 3 9 plus minus 2 into 1, that is 2 divided by 3 into 2 is 6, and that is equals to 7 by 6. And we shall find out the product of zeros. That is alpha into beta. That is 3 by 2 into minus 1 by 3. That is equals to 3 and 3 can be cancelled, and that is minus 1 by 2. Is it clear? So we got sum of the zeros, that is 7 upon 6, and product of the zeros, that is minus 1 by 2. But we also know that we also know that sum of the zeros, that is minus b upon a. What is b equals to? Minus 7. So that is minus of minus 7 upon 6. That is 7 by 6. You can verify it. We got the sum of the zeros as same. And also the product of zeros. That is c by a. That is minus 3 by 6, that is minus 1 by 2. Yes or no? So you can say clearly again that from 1 and 2, from 1 and 2, the relationship is verified. Right? The relationship between the coefficients and the zeros is verified, or the relationship is verified. Is it clear, everyone? So now you must be clear with this, how to write down the sums in a proper manner. Right? How to write down the sums in a proper manner. Clear with this, everyone? Okay. Take a look over it. Done? Okay, good. Now I shall give you some homework. Right? Homework, that means self-study. You do it by yourself. By this same manner that we have already did. Right? I am giving you one or two sums that you do it by yourself. There are some more sums in the textbook that you can practice. Right? So, in your self-study work, you are going to do this sums here. That we are having p of x is equals to 3x square minus x minus 4. The second one we are having polynomial given to you is x square minus 2x minus 8. And the third one, that is quite an important one, that we are having is x square minus 3. See, the term with the variable x is absent here. Right? The term with the variable x is absent here in the third question. So, try to do it by yourself. It is quite a very easy example. You just need to follow these protocols here, these formulas, this method here, and try to do it by yourself. Okay? Write down the questions, then we shall move further with the next topic. Okay. So, let us move further with the next very small topic, that is finding out a quadratic polynomial or forming a quadratic polynomial if the sum of the zeros and the product of the zeros are already given to you. What are given? See, sum of the zeros and the product of the zeros. Let me say that if I am given sum of zeros, that is minus 3, and product of zeros, that is 2. What I am given? Sum of the zeros and product of the zeros directly I am given to. That let us say that minus 3 and 2 are the sum of the zeros and product of the zeros respectively. Then first of all we shall take the relationship between the coefficients. So let the required polynomial be p of x equals to ax square plus bx plus c. This is our required polynomial. So if it is our required polynomial, then taking the coefficients out, we shall know that sum of the zeros is equals to minus b by a and product of zeros is equals to c by a. But we are given that sum of zeros equals to minus 3. So minus 3 is equals to minus b by a. Note that the denominator here is nothing that you can see. So you shall put the denominator as 1 and again 2 is equals to c by a. So again putting the denominator here as 1, we get 2 upon 1 equals to c by a. Now what you are going to do is simply compare them. Comparing the numerator to numerator and denominator to denominator. This can only be done when the denominators of both the ratios are same here. See, when this can be done is the denominators of both the ratios, that is minus 3 and 2, the values given to you must be same, because in this b by a minus b by a we are having denominator as a, and in the c by a also we are having the denominator as a. So if it is a and a in the denominator in both both the cases, that means the denominators in both the cases must also be same. So directly writing from this that minus b equals to minus 3 and a equals to 1, this you can write it like b is equals to 3, cancelling out minus on both the sides, and from this I can write c equals to 2 and a equals to 1, right? So we got the values, therefore a equals to 1, b equals to 3 and c equals to 2. Replacing a equals to 1, b equals to 3 and c equals to 2 in our required polynomial, therefore the required polynomial is p of x equals to x square plus 3x plus 2, right? X square plus 3x plus 2. This is our required quadratic polynomial. You can verify what is a here 1, you can verify what is p here 3 and c here 2. So minus p by a, that is minus of 3 by 1, that is minus 3, and c by a, that is 2 by 1, that is 2. So sum of the zeros and product of the zeros are again 3 minus 3 and 2. Is it clear everyone? So this is how you can find out a quadratic polynomial. I am having some more examples here. Let me say, for example, I am having the second one, that sum of the zeros is root 2 and the product of zeros, that is 1 upon 3. So again what we shall do? We shall take let the required polynomial, let the required polynomial be ax square plus bx plus c, right? So from this we can say that sum of the zeros, that is equals to minus b by a, and the product of the zeros is equals to c by a. Therefore what we can do now is simply compare it with the given values. Therefore root 2 is equals to minus b by a and 1 upon 3 is equals to c by a. Now see, as I said, you can directly compare the values when and when the denominators of both the ratios must be same. If you see here, the denominators are not same. Why? Because here the denominator is nothing, that means it is 1. Here the denominator is 3. So what we shall do is, we cannot make 3 as 1. We cannot make 3 as 1, but we can make 1 as 3. How? So we shall multiply this ratio here, that is 3 into root 2 by 3 is equals to minus p by 8. We shall multiply 3 to numerator and denominator in the sum of the zeros. Why? So as to make the denominator of both the ratios same. The intention of this doing is to make the ratios, the denominator of the ratios same. So now comparing, we get a equals to 3 minus b equals to 3 root 2. This implies b equals to minus 3 root 2 and c equals to 1. Right? We shall get these three values by comparing this all. b equals to minus b equals to 3 root 2. Therefore b equals to minus 3 root 2 and c equals to 1. Therefore the required polynomial is p of x is equals to 3x square minus 3 root 2x plus 2. This is my required polynomial, 3x square minus 3 root 2x plus 1. Is it clear with this? So again you can get the required polynomials in this way also, right? That is the second example. Now I am having an easy trick for you. Very easy. You can get the answer in a single step. This is the easiest one, but this cannot be used if the question is asked in 2 marks or more. Right? If it is asked in a 1 mark question, then you can directly use this trick and you can get the quadratic polynomial. So before that, you need to remember a small formula to find out the quadratic polynomial. That the required quadratic polynomial p of x is x square minus alpha plus beta x plus alpha beta. What does this suggest? Yes, good. Alpha and beta are the zeros of the polynomial. That means alpha plus beta, that means sum of the zeros, and alpha into beta, that means the product of the zeros. Right? So alpha plus beta, that is sum, alpha into beta, that is product. Or you can also write it like x square minus sum of zeros into x plus product of zeros. Right? Note that this x is multiplied by the sum of the zeros. X is multiplied by the or with the sum of the zeros, not with the product of zeros. So don't mistake it over there. Let us take any of these examples that we solved here. So sum of the zeros was -3 and product of zeros was given 2. Therefore, the required polynomial is p of x is equals to x square minus sum of the zeros. X square minus sum of the zeros, that is -3 into x plus product of zeros. So minus minus, that will become plus x square plus 3x plus 2, and that is our required polynomial. That you can easily look over here, that we got the same answer, x square plus 3x plus 2. So what you need to remember is the quadratic polynomial with given sum of zeros and product of zeros is p of x is equals to x square minus sum of the zeros into x plus product of the zeros. Is it clear, everyone? So that is the formula, or that is the short and easy trick that is to be remembered. Right? So again, I shall give you some 2 or 3 values of the same kind. Do it by yourself and try to solve it, try to get the answer. You can also get some of the examples from the textbook or either from the exemplar textbook, right, or from the exemplar book. There is a practice book also available to you. You can get it over there also. Right? So let us see some of the examples I shall give you. The third one, that is 1/4, or let me write down the whole thing. Sum of the zeros is equals to 1/4 and product of zeros is equals to minus sum of the zeros for the next one, that is equals to 0, and product of zeros, that is good. And fifth one, I am having sum of zeros equals to -1/2 and product of zeros is equals to 1/2. Right? So you can solve this 3 examples by yourself, get the answer and verify it with the text. Is it clear here? Take a look over this. Okay. So done. Good. Now we shall move on to the last topic of this chapter, that is the division algorithm of the polynomials. the division algorithm, or basically the division of the numbers. But here we shall not have the numbers, we shall have the polynomials. Right? So how to divide the polynomials, that I think you have already studied some in standard 9, and we shall take a broad concept of this in this chapter right now in this talk. So let us start it with the division of the polynomials. Division algorithm for the polynomials. The division algorithm. Now, if we are dividing two numbers, then the division algorithm follows that dividend. The division algorithm follows what? I am saying about two numbers right now, not for the polynomials. The division algorithm follows like dividend is equals to divisor multiplied by the quotient plus the remainder if any. Right? If there is any remainder, then that is added. If there is no remainder, then that is not added. That means zero. It is zero. Right? Now, this is the algorithm that follows for the numbers. Let us say, for example, if I am having a number 95, that is to be divided by 4. Right? I am having a number 95 that is divided by 4. So I shall say 4 into 2, 8, 15. Remainder is 15 here right now. So that will give me 4 into 3, 12. And the remainder remains 3. Right? So what can I say? That 95 is written as 23. Sorry. 4 multiplied by 23 plus 3. Right? You can see what is 95 here? The number that is divided, that is dividend. What is 4 here? Divisor. That means the number by which we are dividing 95 is known as divisor. 23 is the quotient that we get here, and 3 is the remainder that is left out at the bottom. So again that same algorithm follows here, that what I have written. But now the only term or the only thing that changes from division of numbers to division of polynomials is each and everywhere we will be having polynomials. That means the dividend polynomial is equals to the divisor polynomial multiplied by the quotient polynomial plus the remainder polynomial. Is it clear, everyone? Dividend polynomial is equals to the divisor polynomial multiplied by the quotient polynomial plus the remainder polynomial. That is what the division algorithm for the polynomial suggests. Right? So you need to remember this. That dividend polynomial equals to divisor polynomial multiplied by quotient polynomial into plus the remainder polynomial. Good. Now let us see. This each and every polynomials has a denotions. That means the dividend polynomial is denoted by p of x, the divisor polynomial is denoted by g of x, the quotient polynomial is denoted by q of x, and the remainder polynomial is denoted by r of x. P for dividend polynomial, G for divisor polynomial, Q for quotient polynomial, and R for the remainder polynomial. So P of x is equals to G of x into Q of x plus R of x. This is the division algorithm for the polynomials. Is it clear, everyone? P of x equals to G of x into Q of x plus R of x. That is what the division algorithm suggests. Right? Now let us see. For example, if I am having two polynomials, x square, or divide 2x square plus 3x plus 1 by x plus 1. So we know how to divide this polynomial. 2x square plus 3x plus 1 by x plus 1. We have already discussed this in standard 9. So let us go by dividing 2x square plus 3x plus 1 to be divided by x plus 1. Right. So how we are going to divide? First of all, you shall look at the first term of p of x and first term of g of x. That means first term of dividend and first term of divisor. Make the divisor term, make the first term of the divisor equal to the first term of dividend. So we need to multiply it by 2x. So that will give me 2x square plus 2x. Eliminating them both, this will be cancelled. This will give you 3x minus 2x, that is x, and this plus 1 will be brought down here. Okay. So now again, note the first term of divisor and the first term of the dividend that we got here are same. So we don't need to multiply with anything. That will give me again x plus 1. Eliminating them both, we shall get the 0 as the remainder. So in this case, if I were to write down this whole thing, the whole division in the form of the division algorithm, then I shall write 2x square plus 3x plus 1 is equals to x plus 1 into 2x plus 1 plus 0. See, this plus 0, I said if the remainder is available to you, then you are going to add up in the division algorithm. But if it is not available to us, then what we are going to do is we are not going to write anything over here as remainder, and hence the division algorithm is 2x square plus 3x plus 1 equals to x plus 1 into 2x plus 1. Basically, what does this mean? This means the factors of the given polynomial. What does this mean? This means the factors of the given polynomial. So, what can you get by division algorithm or by division of polynomials? Basically, we can get the factors of such polynomials which we cannot get it directly by factorizing. Right? Suppose if I am having some polynomial of degree 5, it is not possible for us to factorize it directly. Then what can we do? We can go on dividing by this division algorithm and we can get the factors of the given polynomial of degree 5. Right? Let me take one more example of the same kind, that is dividing 3x cube by 1 plus 2x plus x cube. Right? So again I am having a polynomial p of x. Again I am having a polynomial g of x also. This is my p of x. This is my g of x. One thing I forgot to tell you, that when you are asked to divide the polynomials like this, so that divide this polynomial by that polynomial and divide another polynomial by another polynomial, or check whether the second polynomial is a factor of the first polynomial or not. In that cases, what you are going to do is you are going to select the polynomials in such a way that the degree of g of x, that means the degree of the divisor polynomial must be less than the degree of the dividend polynomial, or vice versa, the degree of the dividend polynomial must be greater than the degree of the divisor polynomial. Right? That means degree of p of x must be greater than the degree of g of x. Note that. What is degree? We have already studied in the starting of this chapter. Degree of p of x here must be greater than the degree of g of x, or vice versa again. Degree of g of x must be less than the degree of p of x. Is it clear? So you are going to select the polynomials in that manner. Okay. So we shall write it down here. 3x cube plus x square plus 2x plus 5 and 1 plus 2x plus x cube. Right? Can you divide this? The first question to you was, sorry, here it is 1 and here it is 3x cube. How can we divide it? So what is the first thing you are going to do is, first of all, you are going to rearrange the terms for g of x. That is, g of x will now be equals to x square plus 2x plus 1. Right? As I said that the terms of any polynomial must be arranged in a manner that the powers of the variables present is in the descending order. So this g of x will now be equals to x square plus 2x plus 1. Now you can easily divide this. Right? So again, looking at the coefficients here it is x square, here it is 3x cube. So we shall multiply it by 3x into x square, that is 3x cube, plus 3 into 2, that is 6x square, and 3x into 1, that is 3x. Eliminating them, we shall get this terms cancelled, 3x cube and 3x cube, right? And what the next thing is, x square minus 6x square, that is minus 5x square, and 2x minus 3x, that is minus x. Bringing this 5 down, we shall get minus 5x square minus x plus 5. So again, comparing the first terms, here it is minus 5x square, here it is x square. So we shall multiply it by minus 5 so as to make them same. So minus 5 into plus 2, that is minus 10x, minus 5 into 1, that is minus 5. Again eliminating them, we shall get the remainder as this will be cancelled. Minus x plus 10x, that is 9x plus 10. Note that we are having a remainder here. In the first case, we were having the remainder as 0. But here, in this case, we are having the remainder here as 9x plus 10. Therefore, 3x cube plus x square plus 2x plus 5 in the division algorithm can be written as x square plus 2x plus 1 into 3x minus 5 plus 9x plus 10. So that is the final step of the sum, that is writing down the division in the form of a division. Now, the thing is, if it is asked to find out the quotient and remainder of this polynomial of the given division, then also you shall perform all the steps here up to this remainder, and then you shall write down that q of x, only q of x is equals to 3x minus 5 and r of x is equals to 9x plus 10. So, if it is asked to write down the division polynomial, then you are going to write down this box, and if it is asked to find out the quotient and remainder, or simply divide the following polynomial by this polynomial, then you are going to write down q of x and r of x in this. Is it clear with this, everyone? So that is the basic division algorithm that we studied in 9th standard and that we again discussed here in this topic. Right? Now, one more thing I would like to do here is I shall give you some sums to perform it by yourself at home and try to find out the answer. Right? So I shall write down the questions here, write it down in your book and then try it by yourself. Divide, or let me write down generally, divide the following. So these are the three examples that you are going to do it by yourself in your book and try to solve them or try to divide them formula, right? You shall write down the division algorithm of all these three and verify it with the quotient and the dividends. Clear with this everyone? So that's it for the chapter, that is division algorithm of the polynomials, right? I am having one more kind of examples for you, that if we are given a polynomial and some of the zeros are given and we need to find out the remaining zeros, then what we are going to do? Right? If we are given some of the zeros, that means if a polynomial is given of degree 4 or 5 or 6 or of higher order, and if we are given any 2 or 3 of the polynomials, then we need to find out the remaining polynomials, right? So how to solve that kind of sums? Let us look over that, and then we shall move to the conclusion part of this chapter, right? Again, this kind of sums are included in the topic of the division algorithm of polynomials only. So we shall move further with this topic only, right? That is the last kind of sums of division algorithm of polynomials. The example given to you is, if minus root 2 and root 2 are the zeros of the polynomial, p of x equals to 2x raised to 4 minus 3x cubed minus 3x square plus 6x minus 2. Then find the remaining zeros. Right? So we are given a polynomial of degree 4 here, right? See, the highest power is 4 here. The highest power is 4 here, right? So we are having a polynomial of degree 4, and how many zeros are given? Minus root 2 and 2. So if a polynomial is of degree 4, then that polynomial will have how many zeros? 4 zeros. That polynomial will have 4 zeros, and 2 of them are already given to us, that is minus root 2 and 2. Root 2 are the zeros of this polynomial. We need to find out the rest of the 2. So what is given here is, let the given zeros, the solution starts from here, let the given zeros be x equals to minus root 2 and x equals to root 2 by x only. Because the polynomial given to you here is a polynomial in variable x, and as we discussed earlier, in a linear polynomial, that the value of the 0 is equals to value of the x. Again, the definition also suggests that that value of variable x at which the value of the variable polynomial is 0 is known as the 0 of the polynomial. So we have taken let x equals to minus root 2 and root 2, because these are the given zeros to us. Is it clear, everyone? So we shall take x equals to root 2 and x equals to minus root 2. Therefore, if x equals to minus root 2, then we can write x plus root 2 equal to 0, and x minus root 2 is also equal to 0. Right? That means if x plus root 2 equal to 0 and x minus root 2 equal to 0. If x equals to minus root 2 and x equals to root 2 are the zeros, then x plus root 2 and x minus root 2 are also the zeros of the polynomial. Yes or no? Yes. Therefore, we can say that the product of this x plus root 2 and x minus root 2 equal to 0 are also the zeros of the polynomial. So we can get the factors like x plus root 2 and x minus root 2. That means x square minus 2 is also equal to 0. So we got a conclusion here that one of the factor of this given polynomial p of x will be x square minus 2. Why? Because x minus root 2 and x plus root 2 are the zeros. If I put this both the values here, this will be verified because root 2 square is 2 minus 2 0 and minus root 2 square is again 2 and 2 minus 2 is 0. So this both are the zeros. So this will be a factor of the given polynomial. Assuming let g of x is equals to not 0 is equals to x square minus 2. Right? G of x is equals to x square minus 2. Now dividing the given polynomial p of x by 2x raised to 4 minus 3x cube minus 3x square plus 6x minus 2 by x square minus, right? This g of x that we assume here, this will be the divisor polynomial now. This p of x given will be the dividend polynomial now. So we shall go on dividing. First of all, we shall get 2x square, that is 2x raised to 4 minus 4x square. See, this term will be missing here. So in place of that, we shall write down 0x cube. So we shall eliminate this. 2x raised to 4 and 2x raised to 4 will be cancelled. Minus 3x cube minus 0x cube, that is minus 3x cube minus 3x square plus 4x square, that is plus x square, and this 6x will get under here. Right, so that is minus 3x cube plus x square plus 6x. That is multiplied by minus 3x. So that is minus 3x cube, right, plus 0x square plus 6x plus minus minus. So again eliminating them, we shall get these two terms cancelled here. So that becomes x square minus 0x square, that is x square, and taking this term over here, that is minus 2. So again there is no need to multiply with any real number over here. Eliminating them, we will get the remainder equal to 0. Note that in this type of questions, in this specific type of questions, the remainder of the division of these two polynomials will always be equal to 0. And if you get any remainder over here, then make sure that you have made the division correct. Because if you get a remainder here, that surely means that you have made a mistake somewhere. Is it clear, everyone? So, writing down the algorithm here, that p of x is equals to x square minus 2 into 2x square minus 3x plus 1. So we got the factors because the remainder is already 0. Finding out the zeros, let p of x equal to 0. Therefore x square minus 2 into 2x square minus 3x plus 1 equal to 0. Therefore x square minus 2 equal to 0, or 2x square minus 3x plus 1 equal to 0. Right? X square minus 2 equal to 0 or 2x square minus 3x plus 1 equal to 0. But you can see clearly at equation number 1 that x square minus 2 is already 0. That we have already verified here. So we are not going to solve this. We are going to solve the next polynomial, and hence factorizing this polynomial we get 2x square minus 2x minus x plus 1 equal to 0. Hence, on the final steps we get 2x minus 1 into x minus 1 equal to 0. Right? Therefore, x is equals to 1 by 2 or x equals to 1. Is it clear or not? So we get on the final notes that x equals to 1 by 2 or x equals to 1. Is it clear, everyone? So these are the two remaining zeros. Therefore, all the zeros of the polynomial p of x are minus root 2, 1 by 2 and 1. So the remaining zeros are 1 by 2 and 1, and all the zeros of the given polynomial are minus root 2, 1 1 by 2 and 1. Is it clear, friends? Right? So take a look over it and then we shall move to the conclusion part of the